All right, so hello, good morning, everyone, and we'll be discussing the Leetcode weekly contest number 385. So the date for today when the contest took place is 18th of February, and I'm recording this video at exactly 11 a.m. Just giving a brief overview as to how this contest was. Unlike the previous contest, I would say for this contest, what really mattered was the speed of how you solve the questions. Okay? Because if you see the logic for mostly all the questions, almost all four of the questions was pretty simple. At least for the first three, one of them, it was pretty simple. So once you read the question, you would have got the approach straight away. And the only gig for this contest was to solve the questions quickly. So it doesn't really matter whether the solution was optimized or not. All that mattered was to how quickly you code those solutions and submit them. Okay. So this was more about testing your coding speed, how quickly you can code. Okay. So for these kind of contests, it's always preferred that again, firstly you solve more and more questions, and secondly you should have a good typing speed. So good typing speed would be somewhere between 70 to 80 words per minute. Okay. So this is what you should all aim for, and yeah. We perhaps can discuss some resources for improving your typing speed if you want. You can. You feel just feel free to write your suggestions or your thoughts on this in the chat section. Okay, so let's move on to discussing the contest. Let's move on to the main task for today. So the contest number is 385. Okay, there were four questions. Okay, so the first and the fourth problem, they were again what you call as same questions but with different constraints. This is what we have observed in the previous contest as well. So let's move on to the discussions for the first problem. Okay. We have been given a zero index string array words. Okay. Let's define a Boolean function is prefix and suffix, which takes two strings, string one and string two. This function returns true if str1 is a prefix and suffix of str2 and false otherwise. Okay. So let's take an example if ABA and ABABA. So if you see ABA is a prefix as well as a suffix for the string ABABA. Okay. So that is why this is a possible pair. Now what do we need to return? We need to return an integer denoting the number of pairs where I is less than j and this function returns true. Okay. So we need to return the number of valid pairs with I less than j and which follow this function. So let's move on to the discussion for this. Let's see the constraints first, in fact. So you see the constraints are pretty simple. Word length is, array length is up to 50. The length of the string is up to 10. So again, we can simply go for a brute force solution. Okay, let's quickly discuss this problem and then we'll see the solution for it. Okay, so problem one, solution. Okay. So what I could have done is easily because I need to count the number of pairs I is less than j and I can go for a brute force solution. So simply let's just write a for loop. Okay. I till n. Okay. Then for j, I'll again write a nested for loop because I can take a brute force solution here. So I'll start from j is equals to I plus 1. Okay. And I'll go till n. Alright. And now I have the pair I and j. Okay. So I just need to check if s of I is a prefix and suffix of s of j. How do I do that? Let's say the length of this is x. Okay. So I just need to check if a prefix of length x for this string and a suffix of the same length of x in this string, if they are both equal to s of I or not. Okay. So I'll take the substring of starting from say 0 till x dot length and I'll take another string from n minus x till x. Okay. So I'll just check if both of them are equal to s of I or not. Okay. I'll just check if s of I and this both of them are equal or not. If they are both equal, I'll increment a count variable. Okay, so I'll store declare a count variable at the beginning only. Initialize it with zero, and I'll just return it. Okay, and this will be all for this question. Okay, so we'll see the solution. Let's discuss the complexity first. Okay, two for loops. Okay, again n square. All right, plus say I think for the substring function, the complexity is O of n. Okay, so this is n this one. Okay, so this becomes O of n cube as the time complexity, and because we are not using any additional space, so that will be O of one. Okay, so yeah, this will be the complexity. Now let's see the code for this quickly. Okay, simple code, not much to discuss. Okay, integer answer is equals to 0 for storing our count or answer whatever you want to say. The first loop, as I said, starting from 0 till the end of the array. Then the next loop, starting from I plus 1 till the end of the array again. Alright. And yeah, we'll compare now. Okay, if words of I is equals to, as I said, the substring of length x from beginning, x is equals to the length of words of j. So 0 till words of I dot size. Okay, and words of I is equals to words of j dot size minus words of I dot size. This is what they have done. Okay, as we had discussed, let's say we replace words of j dot size by n and words of I dot size by x. So this would be the same thing, n minus x. Okay, so yeah, and sorry, and if we see them as same, then we'll increment our answer variable and we'll return the answer. So that is the code for this question. If you let's just check it on the sample cases. Again, it will still get accepted. I will, yeah, I'll submit this. So this is how the solution would work. Okay. Pretty simple question. I hope everyone would have solved this question. Not more than let's say, couple of minutes are needed to code this if you really want to get a good rank in this contest, particularly. Okay. All right. So let's move on to the next question. Find the length of the longest common prefix. Okay. You're given two arrays and positive integers ARR1. Sorry, you're given two arrays with positive integers ARR1 and ARR2. These are our two arrays. Prefix of a positive integer is a number formed by one or more of its digit starting from the leftmost digit. Okay. So you know everyone knows what a prefix is. Okay. A common prefix of two integers a and b is an integer c, such that c is a prefix of both a and b. Okay. So common prefix again it's self-explanatory. It explains for itself. So we need to find the length of the longest common prefix between all the pairs of integers, such that x belongs to ARR1 and y belongs to ARR2. Okay. Return the length of longest common prefix of all the pairs. If there is no common prefix, then you return 0. Okay. So we need to find the length of the longest common prefix between all the integers such that one of the integer belongs to ARR1 and the other integer belongs to ARR2. So we need to return the longest common prefix length for both of them. Okay. And we need to return that length. Alright, this is what they are asking. So let's again, it's a brute force solution kind of a thing that you'll have to count for. Let's discuss it on the whiteboard. I discuss it here. Okay. Yeah. We need to return the longest. Let me just confirm length of the common prefix among all the pairs. Okay. If there are no common pairs. Okay. If you have you got X belongs to. All right. So what we can do in this question? Problem two. Solution. Okay. Simply what we can do here is that we iterate over all the elements of array 1. Okay. And for each element we store all its prefixes. Just to clear this thing as well, the constraints. The constraints are 5 into 10 power 4 and the numbers are between 1 to 10 power 8. Now this is a very important constraint. I'll tell you why. Okay. So if let's say if this is a number 10 power 8, okay, I what is the length of this number? 9, right? Okay, I want to check all the prefix of this number, all the prefixes of this number. So what would be the complexity of that? Okay, I can simply convert it to a string, or I can take that digit, extracting digit by digit, and that way also can work. Okay, so I'll just do either one of them, but the complexity in each of the case would be O of length, length of string, which is O of 9 and which comes out to O of 1. Okay, so this is constant. So this is very important that now we'll not do a nested loop. We are just doing a constant complexity operation. Okay, that is I firstly like let's say convert it to a string. Okay, and then I iterate over that string I is equals to 0, e dot length. Okay, and I'll append the characters. Let's say prefix is stored in an empty string like that. So we'll do prefix is equals to prefix plus e of I every time. Okay, this is the prefix, and we'll store this prefix in a map. Okay, we'll maintain a map for string comma integer for storing the this thing string. So we'll every time we'll do empty of p plus plus. Okay, this is what we are doing. So this is the first part. Now for the first array we have done. Now only we need to check the same thing for the next array, and we need to check if any prefix of array 2 is present in this map already or not. If it is, then we update our length. Okay, let's say our answer is stored in length, which is initially 0. So I'll just iterate over this again. Let's move on to a new page. Okay, so I'll again write a loop array to, okay, convert this to string. Okay, str. Again, this is kind of a pseudocode. You'll see the exact code for this. Okay, iterate over all the characters. Okay, of e. This is an empty initially, so p is equals to p plus c. Okay, and we'll see if empty of p. If this is already greater than 0, if it is, then update the answer. Sorry, spare my handwriting, please. Max length, comma, p dot length. Okay, this is what we are doing, and we return our length variable. That is the maximum length coming out. Okay, so well, let's see again. So this complexity would be, now let's discuss the complexity. The complexity would be O of n only because we are iterating over the array only. This is a constant complexity case. Okay. So this is O of n, and similarly for the next loop. So this again comes out to be O of n. The space complexity for storing all the prefix, that would be, let's say, if I say all the strings have a maximum length of whatever they had given constraint. Okay, that is all the numbers are 10 power 8. Let's suppose that. Okay, so for store 8 prefixes for every string and n strings. So the space complexity would be n into 8, which is again O of n. So time complexity is also the same and the space complexity is also same. Okay. Now let's see the code for this. Okay. In the code, I have done this question by using the division operation, not by doing the string one. Okay. But it was easier to explain the string one. The logic is still the same. It's just that I'm treating everything as numbers here. Whereas in that explanation, I was treating it as a string. I have firstly converted it to a string. Okay. So iterate over the first array, extract the element, okay. While it is greater than 0, we'll add it to the map, okay, and I'll divide it by 10 every time, okay. And similarly, let's say here I have stored it in another map, okay. That's it. All I'm doing here is that answer is equals to 0, All right. I'm just checking if both of, let's say if this, now I iterate over all the elements of the first map and I'm checking if it is present in the second map or not. If it is, then I'll update this length variable. I'll now convert it to a string and I'll update my answer. Okay. You could have removed this map and you could have straight away added the code which we had discussed, like extracting the strings every time, checking if it is present in map one or not. Okay. So that is again a simpler one. I just did it quickly, so that is why it's a bit less optimal, but the space and time complexity are still the same. Okay. So yeah, that's it. So I hope everyone was able to understand this question. This was again an easy question. Let's move on to the third question. Okay, this was also a brute force kind of a question. Okay, let's read the question. So we have been given a m into n in zero index 2D matrix mat. For every matrix, you can create numbers in the following way. There could be at most eight paths from the cells, namely the eight directions, east, west, north, south, all of them. Okay. Select a path from them and append digits in this path to the number being formed by traveling in the direction. Okay. What this means is that, let's say if I take a number and I start traversing in this southeast direction. So the numbers which I'll get is 1 and 1 9 by appending. Similarly here, from going south, what I'll get is 1, 1 9 and 1 9 1. These are the numbers, okay? And in the third point, that is what they're saying. Note that the numbers are generated in every step, okay? That is, if the digits along the path are 191, then there will be three numbers generated. That is 1, 1 9 and 1 9 1, okay? Return the most frequent prime number greater than 10 out of all the numbers created by traversing the matrix, or minus 1 if no such number exists. Okay. And if there are multiple numbers with the highest frequency, then you need to return the greatest of them. Okay. So what they are saying is that you need to do a traversal from every number in a certain direction and you need to tell us that what is the greatest prime number with the maximum frequency you can get. Okay. So the first constraint is again the maximum frequency, not the greatest number. We need to tell the greatest frequency number. If two numbers are having the same frequency, then we need to return the greater one. Okay, this is how we are solving this thing. All right. Constraints, let's see, the constraints help us a lot in this question. Because if you see the size of the matrix is at max 6 by 6 and the numbers are between 1 to 9. Okay, so this solves a lot of our problems. Okay, that is the numbers are single digits and the size is again very small. So you can again go for a brute force solution. So what would be the brute force solution for this is that you take every number and you traverse in every direction from that number because you do not know what the optimal direction is. Okay, and you generate all the numbers from all the directions. At the end, whichever number gets the greatest frequency, you return that number. Okay, because either ways, if even if for all the numbers, if you traverse in all the directions, okay, or you traverse in only a single direction, the greatest number would always be the same, that greatest frequency number, okay, that would always be the same. So it doesn't really matter. Okay, so let's see. Again, it's a pretty simple question. Not a lot to discuss with the approach for this, but let's still do it. Okay. Problem three, solutions. Okay. All all right. So let's say this is our matrix. Okay, I take this number. So for this number, I'll traverse in all these directions wherever it's possible to traverse. Okay, these three directions won't be possible because that would go outside the grid. Similarly, for let's say another number, for this it's possible to do the eight directions. So uh, I'll do these eight directions. I'll check all the numbers. Okay, and I'll add them to a map. ठीक है map would store again let's say that integer comma integer. This is the let me take a different color. This is the number. This is the frequency. Okay, that's all we are doing, and we just need to check the maximum frequency from this map, and we need to return that number. Okay, that's all we will do. Mm. So let's see the code for this straight away. Okay. Also, Akshay, you need to know how to check a prime number. Okay, so again, that is pretty simple. That's a prerequisite for this. You can easily find it from the internet as well during the contest if you do not know this. Okay, so again, this thing we have created a row column for the eight directions. Okay, an ordered map for storing the numbers and the frequencies. We'll run a nested for loop. Okay, for these two loops are giving us the number, and the third loop it is giving us which direction we are moving. Okay, so this is our digit. This is our row column, which gives us the direction. All right. While these values are greater than zero, or let's say within the matrix, we'll go on appending the digit every time and we'll check if it is a prime number or not. If it is, then we'll add it to our map, else not. Okay. And see, we need to also check if the digits are greater than 10. Okay. So these are the two checks, and we'll appending row and column every time. All right. Uh, yeah. Yeah, that's it. That's it. Now if map is empty, again we just return -1. And if it is not, then we'll check for the maximum frequency and for the maximum number accordingly, and we'll return the answer variable. Okay, just give me a minute. I'll be back. Yes. Yeah. I hope this was clear to everyone. Okay. So yeah, that's all we are doing. Let's discuss the time complexity for this one because not much to discuss in this question. Again, a brute force solution. Iterate over the matrix, go in the directions then, and then keep on going until you get all the numbers, until you don't go out of the grid. Okay, and then add every step, add them to the map if they are not if they are a prime number greater than 10. Okay. So the time complexity was the first was n square for traversing these and the eight directions. Okay. So in the worst case, let's say it could be somewhere between O of n cube because from every number we are traversing these directions. So it could go up to blah blah blah. But again, these are very small numbers, so it would be O of 6 cube, very small, O of 1, close to O of 1. But again, if it was a greater constraint, let's say any value greater than 100, then this would have been O of n cube. Okay. So yeah, this is the time complexity. For the space complexity, we are only taking all the numbers. Okay. So that would again be O of n cube. Okay. Because you are taking for every number, you are taking all the directions, all the ways. Okay. So n cube into 8 because for the 8 directions and n steps at max you can go. So this was again the O of n cube. So TC is O of n cube and so is the space complexity O of n cube. Okay. So this again finishes our third problem as well. Wait a minute, where's the mouse? Okay. Now let's move on to the fourth problem. This was a bit again simpler as compared to previous contest, but again a good problem. Okay. You are given a zero index string array words. This is the same as the first question. So I'm not reading this question again. I'm just telling you the constraints for it. Okay. Now this time the constraints are very high, 10 power 5. Okay. And what we were doing is we were matching the prefixes and the suffixes. Okay. So if we keep in mind the discussion we had last week in the previous contest, that is contest number this thing 384. Then what did I discuss? Whenever let's say you have to match any strings with a high complexity, what would you do? The first thing that should come to your mind is algorithms like Z-algo. Okay. Uh, and there's Nut Morris Pratt algorithm. Okay, price all these data structures. Okay, so this question has to be solved by any of these algorithms. if you are comfortable with any of them, then you could have easily solved this question. Okay, that is why these string matching algorithms are very important, because mostly what happens in contests is that students are not aware of these algorithms, because these seem very intimidating at the first go. Okay, and what happens is that you just miss out on a question only because you do not know this algorithm. And that is what would happen when you'd give some, let's say, hiring test for any of the companies. They would put any stupid question like this, wherein you have to solve it using any of these algorithms. So this algorithm would become a prerequisite at that time. And if you do not know this algorithm, you would be stuck in that. Okay, you won't be able to figure out an approach. You would still try to go for a O of N solution, anything like that. But mostly all of you won't be able to come up with any such approach at that moment only. Okay, so it's very important that you know at least one of these algorithms. Okay, the price, of course, everyone knows, but I'm talking about the Z algo, KNP algo, and the other string matching algorithms. So at least one algorithm out of all of them you should know by heart. Okay, and you should know how to code it and how to use it. So that is very important. Okay, especially when you are applying for aiming for any of the MNCs, because this is what they want to, this is what they like to ask in their hiring tests. They won't ask this to you in the interview rounds, but for the hiring test, you can expect any of these algorithms. Okay, any question based on one of these algorithms. Although the problem types for all of them are same, but still. So I have implemented this using a try. Okay, I'll quickly just discuss my solution, because this again goes for a prerequisite. Okay, what we are doing here is that, still I'll give you a brief idea as to how I'm solving it. Okay, okay, what I'm doing here is that I'm creating a try. Okay, which has a hash for my prefix and suffix. Okay, and an integer. So a try would have a map only. Okay, this time. So map, yeah, this thing, okay, integer and this hash. Okay, this is what I am storing in my this thing. Try this time. All right. This is my try node. Now just to again, we when we see the code, you'll get a much better idea. Okay. So this is what we are storing, and every time, let's say for every string I iterate, okay, I'll prepare a hash of its prefix plus its suffix, a hash for it, okay, and I'll push it to my try node, okay. Let's say this node I have this hash. Then I go to the next character, would have another character appended to it and another character appended to the end, and would have another hash. Wait a minute, yeah, would have another hash, and similarly like this, okay. And then I iterate over another string. Let's say I currently this hash was prepared for the ith one. Then I'll go for the I plus one and I'll check if the hashes match at any step. Then I'll increment my answer, because at that step I know that they are having a common prefix and a common suffix. So I'll just increment my hash at that step. Okay. This is what I'm doing here. So if you see, this is my try node. It stores a integer comma try node again. So try node is this thing only, integer comma map. So again, try node is the map only, and a count variable for storing the answer for every node. Okay. All right. For every node, I know how many matches I have gotten. So I'll just initialize my this thing try node, result as 0. Okay. I iterate over the words, take the root node every time, and I'll append the characters. Okay. So this is the hash I'm using. Multiply this by 128 plus n minus I minus 1. This is again a very common hashing technique. Look for this on the internet once. Okay. You'll get these things with time. Okay. So you can, in fact, you can use any greater number as well. It's up to you. And yeah, you'll add a character from the beginning, then from the end, and insert it into the try, and update the result every time. If you already found it, of course. And at the end, you will increment a variable, a count variable as well for the string completely. Okay, because this, excuse me, this we are doing for The prefix and suffix. What if the prefix and suffix is the complete string only? So in that case, we need to increment the this thing counter for that pointer as well, for that try node as well. In case I'm checking the prefix and suffix for a complete string, let's say string chirag. So the prefix is chirag and the suffix is again chirag. So I'm checking my complete string instead of chi or rag separately. So I'll increment a variable for that, increment this counter for that, and I'll return the result. That's all. Again, once you go through this, once you go through these algorithms, it would be a lot more easier for you. Okay, believe me, it could have been solved easily by using KNP or Z algorithm. So you can try those algorithms, but it's all that you need to understand that on your own. Okay, but if you guys want, if you guys are interested, you can write your suggestions in the chat section. If you guys want me to discuss these algorithms separately, so I can make videos for these algorithms separately, but a lot of it would depend on whether you guys want that or not. Okay, so let me know in the chat section, and yeah, this would be the solution. So again, I've already run it, it's giving me the correct answer. You can submit it, and you can see the correct solution. Okay. So yeah, let's move on to the next page. So this again finishes the discussion for this contest. Okay. Again, a simpler contest, I would say, for the first three problems. But the thing was, in this contest, if you want to have a good rank, either you solve the first three questions very quickly, but the best case was to solve all the four problems. Okay. So the first problem, I'll rate it as 1 out of 5. Second one would also be 1 out of 5. The third problem, uh, second, third, because it's a bit lengthy to code, so I'll give it 2 out of 5, and the problem 4. That would be 3 out of 5 again. Okay. So yeah, that's it. I think half an hour would have been sufficient if you know all the algorithm for the fourth question. So half an hour would have been sufficient to complete all the four questions, and yeah, that finishes the discussion. I hope everyone liked this video. Please feel free to ask your queries and give your suggestions in the chat box below this video link. Okay, and please share it more with your friends so that I get motivated to prepare more such videos. I've been noticing that less students have been watching this, but again, if you have any issues with that, please feel free to write your suggestions in the chat box. If you think that I can improve by any chance, okay, if you want me to cover any particular thing or pay stress on any particular aspect of this discussion, then I can do that. But for that, you'll have to let me know if you actually think that yeah, I can do some improvement on this. So yeah, that's it. So let's meet up in the next discussion. It could be a bi-weekly or a weekly. Let me know again if you want discussions for bi-weekly regularly as well. So we can discuss that as well. Okay. So till that time, happy learning and have a great weekend, everyone. Goodbye.